You may have seen recently at the Bathurst 500, we delved in with one of our really great partners, Repco Filters, and had a close look at the filtration systems on our V8 supercars. Air, oil and fuel. And quite frankly, I was quite blown away by the development work that had happened to put these filtration systems, bespoke if you like, into our cars. So I wanted to come down here to Altona North, just out of Melbourne, to actually get a sense of just what's going on in Repco Filters' world and the development of their supercar filtration systems. Let's take a look. So the first thing you need to know is Repco is an Australian company, and that's why they felt the need to build essentially workshops and 200 odd square metres of laboratory here so they could test for Australian conditions, because they're not a company that's going to bring in cheap imports and junk and just throw them at your car. They develop their products, and that's why it was such a great fit for supercars, because we needed specific products developed for our Australian race cars. So let's hear from Alistair Hampton, who's basically head of everything engineering and technical here, as to why on earth they needed a laboratory in a filtration business.
One of the important things for us at Repco is it's not just about having a really good range of filters, oil, air, fuel, cabin for all the passenger vehicles and trucks and other vehicles that are in the Great Australian and New Zealand car park. For us, we want to push the boundaries on increasing the longevity of engines as much as we can, because with longevity of engines comes good efficiency, low emissions. And so for us, it's important for us to really understand filtration, especially in Australian conditions, so that we can maximise that longevity. And the only way we can really maximise longevity is with filtration, because 70 to 80% of all engine failures is due to wear. So Australia has a unique geology that involves a lot of really fine dust. I think a lot of people, a lot of your viewers would know that when you go out to the country, you go out to rural areas especially, you go down an unsealed road, they'll drive down that dusty road and they'll see dust that just hangs in the air for a very long time. That's really fine dust, and that's quite unique to Australia. We have a lot of really fine dust in Australia, and it's a lot finer than other countries where most vehicles are engineered and developed now. And so for us, we really want to tackle that fine dust, because we know that's what gets into engines and really shortens engine life.
So you just heard Alistair say it, Australia's got unique conditions, and we've also got unique racing conditions. So bringing it back to supercars, one of the key agendas for Gen 3 was to try and get engine longevity out thousands of more kilometres. Now we're getting close to 10,000 kilometres between engine rebuilds. Not quite there, but nearly there. Now I come from an era where we used to get 1,500 kilometres, and Craig Hasted, our own supercars engine expert, contributes so much of this to really good oil and fuel filtration. Remember at Bathurst, say at the 1,000, nearly 100% throttle all day. Oil temperature maybe 130 degrees, 120 degrees, way hotter than your road car. So oil and fuel filtration, really critical. So again, let's hear from Alistair about what they specifically did to develop these items for supercars.
The teams are hard to keep happy, but we also had a new customer, and that was called Supercars. And Supercars really wanted to get that longevity. They wanted to have engines and engine systems that didn't require constant upkeep and maintenance, and the only way we could really do that is by keeping the engines extremely clean. Much cleaner than what a traditional OEM filter would do. And as an example, what's on test right now, that's a Z5000 RP fuel filter. That's the Gen 3 supercar fuel filter. Now a typical road car fuel filter would normally filter to around 18 microns, and look, a micron, it's a thousandth of a millimetre. That's the microscopic world that we operate in. 18 to 20 micron. This filter for supercars, that's filtering down at 7 micron. And the reason why we want to be down there is because this fuel filter has to handle a massive volume of fuel, and we cannot afford any contamination whatsoever, because every little bit of contamination that goes through that fuel system, goes through those injectors, will create minute amounts of wear. And on an injector, we're not just worried about blocking the injector, we're actually worried about the profile of those holes. If we keep those holes clean, we get really good fuel atomization, which means the engines run really efficiently and they make maximum power. But most importantly, they make that power all through the season with no interruption. So this test rig at the moment, it's pumping some dirty fluid through the filter, and we're monitoring the amount of particles upstream and downstream of that filter, and not just the quantity of particles, but we're actually cataloguing the exact sizes of each particle so that we know the percentage by particle size that we're actually removing from the fluid. And that gives us a really good fractional efficiency. We do the same kind of testing on oil filters, where again, we're looking at the particle sizes that are actually coming through the fluid. In the case of a typical road car filter, oil filter, they'd usually be around the 35 to 50 micron is in their ability to remove contaminant. For supercars, we're down to 20 micron. And in fact, down at the even finer micron size, we're still actually pulling out significant amounts of fine micron. And that's because those engines are working so hard. The RPMs, they're living at 7,500 RPM. You can imagine those metal surfaces sliding past each other extremely rapidly at very high speed. Any contaminant that gets in between those metal surfaces is going to do huge damage. And again, it's going to destroy that longevity within a matter of a race. So when we were looking at the program, obviously we knew what longevity we had to achieve, which meant we knew the micron that we wanted to hit with the filter. But then we had this whole issue of flow, because we knew that the teams in supercars wouldn't adopt our filters unless we also created filters that flowed better than the incumbent filters that they were using.
I know one of the things that race teams are absolutely passionate about is they think that when you over-filtrate or filter something, doesn't matter if it's air or oil, they think you're going to have restrictions there. That's not the case. So that fuel filter we just showed you, which will flow at 400 litres an hour, will actually filter your red blood cells out of your plasma. That's the level they go to. Unbelievable. And in fact, they just showed me, Alistair just showed me these graphs here. Now, we don't want to bog down on graphs, but here's some other competitors. And Repco, you can see in terms of filtration, market leading against the other leading brands. And this one down here, they're again showing less restrictions. Now that's fuel and oil, but there's more. In behind the secret door here is air filtration. Okay, so this is the second part of the laboratory dedicated to air filtration. Now, think about air filtration in our world. Supercars, you see them all the time. Come over a curb, kick up dust, a car coming by at 250 k's an hour. Just think about what that consumes. So they've got a dedicated air box off a supercar here, or the air intake, into this machine. But don't worry about what I've got to say. Let's hear from Alistair about this fantastic device.
So you only need milligrams of dust being ingested through the air intake to do a lot of damage to an engine. And traditionally, a lot of racing engines run minimal filtration because they're mainly concerned with flow. And they would get that flow from the expense of filtration. They'd run really open weave filters, and that's really detrimental to longevity. The air filter is probably the most important filter on the engine because that's where the contamination is coming in the first place. And in the case of a V8 supercar, it's inhaling upward of 20,000 litres a minute of air. And if there's any dust in that air, such as the dust that hangs up when someone clips an apex, that instantly goes into the engine, does a ton of damage on the way through. We know that if you want maximum engine longevity, we've got to control, again, we're talking microns, we've got to control that engine air intake particle size down to around 5 micron. A lot of even OEM factory filters run probably at the 8 to 10 micron range, so not enough. And especially on a race car where you've got that high RPM, that high airflow, what we wanted to do was offer down below 5 micron. The only way to do that and maintain flow, like we do with the oil and the fuel, we had to have a special design and a special kind of media that would actually maximize both flow and efficiency, which is why we created this very interesting looking honeycomb filter. But this enables us to get the quantity of media we need. And the media, I can tell you, it uses nanofibers, so very, very high technology. It enabled us to get that fine filtration performance with massive flow. And then of course, the rig behind me right now, which is running a Camaro airbox, it's pulling up, I think, up to 30,000 litres a minute. It's also going to inject a bunch of dust into that filter. We're going to measure the quantity of dust that's been caught in the filter. We're going to measure the quantity of dust that gets through the filter. And interestingly, the thing that makes this rig extremely unique in the world is that not just are we able to measure the mass of dust that comes through the filter, we can actually, again, we can see the particle sizes, we can see the number of particles and the size of the particles getting into the theoretical engine on this rig. And that's what we need to develop the best filters in the world, which is what we've done right now with Supercars. Supercars has such a huge following. Millions of people tune in every year to watch Supercars. And for us, it was a great and a very public test of the efficacy of our products. The fact that we could work with Supercars for filtration perspective, it's a perfect, highly accelerated environment where we've got engines that are running in such highly stressed configurations and running in a high stress environment that for us, if we can get those engines to go the distance, imagine what we can do for a passenger car or especially a heavy duty truck. And so we were able to, while working with Supercars, not just learn a lot about racing, but we could learn what it would take to get extremely highly stressed engines to go the distance. And again, we're not just interested in making engines not break down, we're interested in making the engines run efficiently and with maximum power throughout their entire life.
I've stood in a few dyno rooms in my day, but you know, this is the first time I've actually felt the airflow at full noise of a supercar engine. That's what's happening right there, right now. So let me summarise by saying I've seen a lot of commercial partnerships in our world over many, many years. And I mean it when I say this one really, really works. And it works because you heard from Alistair what Repco get from this, but I can speak on behalf of our pit lane. I talk to teams, I talk to engineers, I talk to our engine gurus, I talk to our engine builders. And they love what Repco are doing for supercars. They love what they're doing for the longevity of the supercar engine, and they love what it's doing for the performance of that as well. So this is a really, truly good story. And what I love about it personally is it's right here in Melbourne, products and development happening for our Aussie Racing Series here in Australia. What's not to love about that?